Alright, here we are on lesson 3, comparing quantities with percent. So, like I said in yesterday's lesson, we were using that proportion setup, which I want you to write at the top of your paper again. We have part over the whole equals percent over 100. But I said yesterday that today we would use that equation that was at the top of the page, which was part equals percent times whole. Alright, and when you use the percent here, you need to put it in a decimal form. Alright, so today we're going to use both ways, and then from now you can decide which way you want to do, which way you want to set up your problem, unless it specifically says in the directions. But if we look at example 1 here, A, it says the members of a club are making friendship bracelets to sell to raise money. Anna and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce over the weekend? So we're going to set it up both ways. If we set up our proportion first, we know this is 100. They're looking for the percent, so this is our x. And we know they made 54, which is their part, and 300 total is what they need. Alright, if we were going to use the equation, the part is 54 equals, we don't know our x, or our percent, so that will be x, and then our whole is 300. Right, so you can solve either of them. I'll solve the equation for this one. So we divide by 300, divide by 300, and if you do that in your calculator, 54 divided by 300, you get 0.18 equals x, but we know that's the percent. So we would say 18% of the bracelets. And you would get the same number if you solve the proportion. Okay. Part B says Anna produced 32 bracelets of the 54 bracelets produced by Emily and Anna over the weekend. Compare the number of bracelets that Emily produced as a percent of those that Anna produced. Alright, so off to the side here, I'm just going to set up, so Anna made 32 bracelets. That means that Emily made 22 bracelets. Alright, so if we're going to set this up, Emily, her portion is going to be the part, and they want percent of those that Anna produced, so that's going to be the total, or the whole. So if I scroll down a little bit, I'm going to set it up both ways again. So if I'm going to use my proportion, we don't know the percent, so that's what we're looking for. This is out of 100. The part is Emily's number, which is 22, and the whole is Anna's, which is 32. Now if I set up my equation, it would be 22 equals x for the percent times 32. If I divide by 32 on both sides, I would get that 0.6875 equals x. So our answer would be 68.75%. Alright. C says compare the number of bracelets that Anna produced as a percent of those that Emily produced. So same idea as up above, but now we're doing the opposite setup. So our proportion would be opposite. We'd still have our x over 100, but now our part is going to be Anna, which is 32, and our whole is Emily. And our equation over here would be 32 equals x times 22. And if we divide by 22 on both sides, we get that 1.45 equals x. And when we make that into a percent, it would be 145%. Right. Go ahead and flip over to the next page. We've got some more examples here. Something I want you to write at the top, though, just to help you remember. Whenever we see the word is, we're thinking of the part. And then whenever we see the word of, we're thinking of the whole. Okay, just to help you with the setup of these. Number 1 says there are 750 students in the 7th grade class and 625 students in the 8th grade class at Kent Middle School. What percent is the 7th grade class of the 8th grade class? So 7th grade is the part, 8th grade is the whole. So now I'm going to use just the equation. So our part is the 750 equals, I forgot my x. We don't know our percent, which is x, times 625. So now I'm going to divide both sides by 625. And when you do that, you get 1.2 equals x. So our answer would be 120%. B says the principal will have to increase the number of 8th grade teachers next year if the 7th grade enrollment exceeds 110% of the current 8th grade enrollment. Will she need to increase the number of teachers? Explain your reasoning. So we wanted to see if it exceeds 110. That is what we did in part A, and we got 120%. So we would say yes, she will, because the 7th grade enrollment exceeds 120%. Okay, so that's all we have to do there. We've got 2 more here. Number 2 says at Kent Middle School there are 104 students in the band and 80 students in the choir. What percent of the number of students in the choir is the number of students in the band? Okay, so the choir is our whole, and the band is our part now. Alright, so you have to be careful because you can word these sentences in reverse order as well. So if we set up our equation, oh, I don't know why I wrote band there. I said the word band, I meant to write the word part. There we go, that's better. So our equation, so we have our part, which is 104, equals, we don't know our percent, x, times our whole, which is 80. So we divide by 80 on both sides, and when you do that, you get 1.3 equals x. So as a percent, that would be 130%. And then our last one here, at Kent Middle School, breakfast costs $1.25 and lunch costs $3.75. What percent of the cost of lunch is the cost of breakfast? So, lunch is our whole. Breakfast is our part. So if we set up our equation, we need 1.25 equals, we don't know the percent, so x times 3.75. And when you divide by 3.75 on both sides, you get that 0.3 repeating equals x. So when you go to write that percent, when you move it twice, you would still get 33, and then it'd be 0.3 repeating percent. Okay, so this is not much different than what we did yesterday besides that equation. We just need to be very aware of what is the part and what is the whole, and I want you guys to label that in your problem. So if you have any questions, bring those to class tomorrow, and then we will do some more practice.